Today I'm going to cover the real number system. The real number system consists of numbers that you are already familiar with. It's any type of number that you've been introduced to so far up to this point at the middle school level is going to be a real number. Every number that you've ever known is a real number. But what I'm going to do is show you the different sets or subsets of the real number system, how we categorize or sort them into different groups. And what it consists of are 5 different groups. And I'm going to explain each group as quickly and briefly as I can. Okay, the first group I want to talk about is the lowest or smallest group of the real number system. And they are called natural numbers, aka counting numbers. Let's say you are in a car with your parents, you're pulling into a parking lot, and your dad remarks like, wow, there's a lot of cars here, I wonder how many there are. And you decide you're going to start counting. Well, you're going to start counting with the number 1. 1, 2, 3, 4, and so on. You're going to count beginning with 1, and you're going to count each positive whole number after that. Those are what natural numbers are. They start with 1, and they continue each positive whole number after it. The next group of numbers is whole numbers. Whole numbers is a little larger than the natural numbers because it contains one additional number. Now, whole numbers are also all of the natural numbers. If you notice that the natural box of numbers is inside of the whole number group of boxes. So all natural numbers are also whole numbers. But there's one exception. There's one number that is a whole number but is not a natural number, and that number is 0. And you can kind of, I usually tell students you can kind of remember where it first belongs. You'll first find it because 0 has a hole in the center of it. So that is going to be the lowest or smallest set of numbers that you will find 0 in. Our third subset of the real number system are integers. Integers are all of those previous numbers I just mentioned, but also include their opposites, such as the number 3. The number 3 is a natural and whole number, but its opposite is a negative 3. Negative 3 would be an integer, but not natural or a whole number. Now, the only, exception to that is 0. 0 is neither positive nor negative, so it does not have an opposite. Our fourth group of numbers is called rational. The rational numbers make sense. Rational numbers, they're logical numbers, they make sense, they're kind of rational. And the rational group includes all the previous groups of numbers. It includes all the positive whole numbers, their opposites, the number 0. It includes everything that we've covered so far. And if you notice, all those boxes are contained within inside this box. So all of those numbers also are rational numbers. But there's another group of numbers that belong with rational numbers that are neither natural, whole, or integer. Those are fractions or numbers that can be expressed in the form of a fraction. Also decimals. Decimals that terminate or repeat. For instance, you might have, let's take 1/2. 1/2 is a fraction that can be expressed also as 0.5. That is a decimal that ends. It does not continue on with decimal place values. So 0.5 is a decimal that terminates, it stops, it ends. So it is a rational number. Also, you might have a number that repeats, like 0.3 repeating. That is also classified as a rational number. So to recap our rational number group includes every number that's natural, every number that's whole, and every number that's an integer, but it also includes repeating and terminating decimals. This next group is the group that I relate best with. Our fifth and final subset of the real number system. This is the group that we call irrational numbers. That's why they're kind of separated from the rest of the numbers. They're a little crazy. They're off to the side. They're in the same solar system as the rest of the numbers, but just kind of disconnected a little. They still are part of the real number system. It's kind of like all these other numbers are on planet Earth, and the irrational numbers would be our moon. As you know, they're part of our system, but they're kind of off to the side a little bit. Now, all of these numbers, they are non-terminating, which means they never end, they never terminate, they never stop, and they are non-repeating decimals. So they do not repeat and they do not terminate. They're decimals that continue on and on and on, and they're unable to be expressed in fraction form, in standard fraction form. Okay, I have 6 examples here for you that we're going to practice with real quick. Now, our first one is 3/4. This is a fraction. Now, you should know already that a fraction is not going to be found in natural, whole, or integer. So it's only going to go one of 2 places. It's either going to be a rational number or irrational. Now, if you use your calculator and you plug in 3 divided by 4, you're going to get 0.75. So this is the same as 0.75. That is a decimal that terminates. It ends. It does not have any more values to any of these units back here. So it terminates, and terminating decimals will be found in rational numbers. It's rational. So we're going to write 3/4 down here in this group. That is the smallest or lowest group that you're going to find the rational numbers in, 3/4 in. All right, and so we'll just put R as a rational number. 0. The lowest or smallest group you're going to find 0 in is going to be the whole number group. Remember, it has a hole in it. So 0 will be found here. Now 0, because it's also inside the integer box and it's inside the R box for rational, 0 is also an integer and it is also rational. But the lowest or smallest subset it belongs to is the whole number group. So we're going to list this one as whole, integer, and rational. The square root of 25. The square root of 25, let's simplify that first. The square root of 25 equals 5. Now, that's the number we're going to focus on. We simplified it to 5. Now, where would you put 5? Is 5 a natural number? Is it a counting number? If you were to start counting, would you say 5? Absolutely. So the lowest group that the square root of 25 would come in is natural. So we're going to put the square root of 25 is here. So it is definitely a natural number. But because it's natural, it's also all of these. It is also a whole number, it's an integer, and it's a rational number. -2. Natural numbers are not negative. Whole numbers are not negative. But integers can be negative. So -2 would be found here as the lowest or smallest subset that it would belong to. So -2 is an integer. But because it's an integer, this box is also inside the rational number box. So -2 would also be a rational number. Now let's go to pi. Pi can be represented as 3.14. However, pi continues on and on and on. It has a decimal that never ends. What box or group would that go in? Well, that's the irrational numbers. It's like you almost cannot know what the next digit is going to be in the decimal. So pi would belong to this group because it's a non-terminating or non-repeating decimal. And our last example is a fraction. So you're going to probably think to yourself, well, fractions are going to belong here. But let's simplify this fraction first. What is 10 divided by 2? It is also 5. Well, if we go up here, the square root of 25 is also 5. So 5, if 10 over 2 is the same as 5, then 10 divided by 2, or 10 seconds, would have to be a natural number. So 10 over 2 is a natural number. Because it's natural, it is also a whole number, it is also an integer, and it is also a rational number. So 10 over 2 is every group except irrational. Now, I did forget to put my irrational over here, but there we go. I've got it labeled now. And those are where the numbers of the real number system belong. And these are the 5 different groups of the real number system.